Today we're going to be multiplying powers with the same base. So just for review, 5 cubed. In this power, what is the base? 5 is the base, and 3 is the exponent. Okay. So if we want to multiply 3 to the 5th power times 3 to the 4th power, are we multiplying exponents with the same base? Do these two have the same base? And the base is 3. So when we're multiplying exponents with the same base, our base does not change, and we add our exponents. So this would equal 3 to the what power? Can we actually multiply this out? So if we simplify 3 to the 9th power, we would get 19,683. If the instructions tell you to simplify it, well then you would simplify. Otherwise, you can leave your answer with an exponent. So for example, if you're asked to rewrite, your instructions are rewrite each expression using each base only one. If you have to rewrite 11 to the 4th power times 11 cubed, what is the base here? 11. And when we're multiplying exponents, what do we do to the exponent? We do what? I'm sorry? We add the exponent. This would equal 11 to the 7th power. Because the instructions just say rewrite each expression using each base only one. So could we try this again? Let's say we have a to the 4th power times a to the 8th power. What is the base here? A is your base. And what do we do to the exponents? Add them. A to the what power? So let's say the problem is 5 to the negative 2 power times 5 squared. What is the base here? 5. What do we do to the exponent? Negative 2 plus 2. I'm sorry? 5? What's negative 2 plus 2? It's 0. So what would this equal? 1. Any number or variable raised to the 0 exponent equals 1. Let's say we have 2n to the 5th power times 3n to the negative 2 power. So what is our base in this problem? N is our base. So the rule we just learned only applies to n, right? What do we do with the 2 and the 3? What about 2 and 3? Multiply them. So what's 2 times 3? 6. Then we said our base was n. What do we do to the exponent? So my answer would be 6n. Let's try this again. We cannot simplify 6n cubed anymore because we don't know what n equals. Let's try this next one. N squared times n cubed times 7n. Mauricio, what is our base here? N. Okay, so what would you do with that 7? Mauricio, just leave it there was fine. Because look, what is the coefficient to n squared? Invisible 1. Let's say coefficient to n cubed, invisible 1. So if we multiply 7 times 1 times 1, just 7. Then you told me the common base was n. What about the exponents? We add them, so we add 2 plus 3 plus 1. This n has an invisible 1, right? 7n to the 6th power. We have to simplify, and we have c to the 4th power times d to the negative 3rd power times c squared. We have to simplify this. What did our rule say? To multiply exponents with the same base, you add the exponent. Do all of these powers have the same base? No. So what would be our common base? C. This one and this one. So what would we do here? C. We add those exponents, so I would add 4 plus 2. What about d negative 3? We just leave it the same, exactly. So this means c to the 6th power Can I simplify this? Simplify. Who remembers what to do with the negative exponent? Okay, put it in the denominator. Let's try this again. Let's say we have a times b times a to the 5th power. What is our common base? A. We say a. What about the exponent? 1 plus 5 would be correct. What about b? Just b. So my answer would be a to the 5th, a to the 6th power b. Can I simplify this anymore? No. Try another one. Let's say we have 5x times 2y to the 4th power times 3x to the 8th. The first thing we need to do is we need to identify our common base. Do we have a common base? X. What about our coefficients? We multiply them, so we're multiplying 5 times 2 times 3. Yes or no? What's 5 times 2? 10, and 10 times 3? 30. Then we said our common base was x. What about the exponents to x? 1 plus 8, or 8 plus 1. Do we have any other variable? Y right here. What do we do with that? Just stays the same. It doesn't have anything else in common. 30, x to the 9, y to the 4th power. We were multiplying numbers in scientific notation. Let's say we have 7 times 10 squared times 4 times 10 to the 5th power. What's our common base here? 10 is our common base. So that makes 7 and 4 what we're multiplying, right? It compares to our coefficients in the previous problem. Yes, this is it. What's 7 times 4? 28. Times 10, our common base. And what do we do with the exponents? Add them. 28 times 10 to the 7th. Is this our final answer? No, why not? Very good. So the scientific notation is not correct, right? So how would you change it, Lionel? Okay. Like here, right? So 2.8 times 10 to the 8. Let's say we have 9 times 10 to the negative 6th power. We have 7 times 10 to the negative 9th power. What's 9 times 7? 63. Our common base? 10. 63 times 10. Negative 6 plus negative 9 is what? Negative 15. Lionel, do we leave it like this? No. What do we do? Move the decimal once. That means 6.3 times 10 to the negative 14th because we added 1 when we move the decimal. Very good.